Welcome to my Container Day 2022 session on towards cloud-native platforms. I'm Lothar Wieske, an enterprise architect and solution architect focusing in cloud-native computing, analytics, artificial intelligence, and deep learning. I put special emphasis on understanding and managing how people and enterprises understand and learn about new technologies and architectures. So during the next about 30 minutes, I will present you my view on the why, how, and what of cloud-native platforms. We will see an evolution matrix to understand the transitions from the mainframe era to the client-server era and to the cloud-native era along two dimensions: the cultural organizational dimension and the architectural technological dimension. Agile and DevOps are just not enough to address the challenges in the cultural organizational dimension of cloud native in general and cloud native platforms in particular. I will propose and present a model based on team topologies and cloud native landscape to restrict the cognitive load on teams and flatten the otherwise steep learning curve for organizations during adoption of cloud native computing. Let's first look at one page in a small ebook of Gartner released at the end of 2021. The core message is a bold one. Gartner predicts that by 2025, cloud-native platforms will serve as the foundation for more than 95% of new digital initiatives, up from less than 40 in 2021. Gartner's ebook is titled Top Strategic Technology Trends for 2022 with the subtitle 12 Trends Shaping the Future of Digital Business. And the author is David Groombridge, an analyst for infrastructure and communication services. He recommends IT leadership to deliver on three major innovations. First, engineering trust. Second, sculpting change. And third, accelerating growth. Cloud-native platforms build the fourth trend in the category engineering trust. Another one in this category is data fabric. An example for sculpting change is AI engineering, and another one in the category accelerating growth is autonomic systems. I highly recommend this ebook for the valuable selection and organization of trends, not only with respect to our quote on cloud-native platforms. Even if their 95% judgment is too generous, you might accept the general direction and ask yourself whether you are prepared for, let's say, 80% or more in about 3 years from now on. Or put the other way around, if your adoption has not run well so far, and you would find yourself in a position to serve the, so to speak, other 5 or 20% in 2025, what does that mean for your future business? With cloud-native computing, containers and their orchestration have become something like the brick and mortar of modern IT architectures. You can really build and construct with them at the impressive shipping container art installation Quartier de Container in Le Havre might show. Let's now have a look at the evolution of information technology. The first mainframe system for the mass market was an important milestone for software applications. After IBM introduced the System 360, the company laid the foundation for porting later applications and upgrade versions. These no longer had to be rewritten completely. From then on, mainframes were designed as powerful central computer systems that users could access simultaneously via a terminal consisting of keyboard and monitor, and they could share their computing time. With the introduction of the microprocessor, the era of the personal computer began, and in the late 1980s, the client-server model also became popular in companies as it allowed better resource planning and distributed work intelligently across different PCs. This led to another effect on software design. Part of the tasks were done on a central server, and clients forwarded the workloads to the server, requiring the server and client applications to communicate with each other. Amazon Web Services kicked off cloud computing infrastructure as a service in 2006. Amazon's initial ideas, and soon Google and Microsoft followed, were based on infrastructure with virtualization in mind. Today, most efforts are based on infrastructures and platforms with containerization in mind. To take full advantage of these cloud-native architectures, enterprises rethought their application development and deployment models as the cloud evolved. This slide only shows a very abridged view on the main eras, but these will help us to understand and differentiate more clearly between cloud-native and former eras. The matrix on this slide shows what we will cover in the rest of the session. We will analyze the transition to cloud-native along two dimensions: an architectural, technological dimension, and a cultural, organizational dimension. During the mainframe and client-server era, the main mantra of IT strategy was industrialization of IT. We will see that we need more flexible views on both dimensions to shape a co-evolution of the architectural, technological, and the cultural, organizational dimension for cloud-native. There are no sharp boundaries between mainframe, client-server, and cloud-native. Transitions between them take their time and effort. And many companies prefer smooth transitions without leaving a certain technology completely. So it's more a concurrent phasing in and phasing out, and quite a number of current companies are currently invested in all three: mainframe, client-server, and cloud-native. For our further discussion, we will have to fill the matrix shown. The three columns in the matrix are our technology eras or phases, if you like: mainframe, client-server, and cloud-native. We see in addition two rows according to the dimensions we have to look at: the cultural, organizational dimension and the architectural, technological dimension. Let's first just have an isolated look on the architectural, technological evolution. You just see the lower row of the matrix in the slide before, with a selection of just a few architectural and/or technological paradigms involved. Some of these can be clearly associated with a single era. You find them in the first, third, and fifth row with respect to failure anticipation, hardware elements, and localization of information technology competencies. On the other hand, we have other paradigms marking the boundary and/or transition from one era to another. These are scaling modes and coping with availability and resiliency. I do not want to just read it, but I give you a moment to have a look for yourself. The Industrial Revolution brought the transition from hand production in small family businesses to machine production in large factories during the last centuries. The first industrial revolution in the 18th century substituted human and animal labor for mechanical labor. The development of mechanized transport systems changed the foundations of economic systems and prepared the global economy. The second industrial revolution began with the discovery of electricity. Henry Ford carried over ideas from a slaughterhouse in Chicago into automobile mass production and assembly lines. Now the vehicles were produced in partial steps on the conveyor belt, significantly faster and at lower cost. The third industrial revolution began through partial automation using memory programmable controls and computers. We are now able to automate entire production processes, and robots are just one example how to perform sequences without any human intervention. And now, digitalization. That means so much more than reduction of transaction and production cost. We will have to organize social changes to enable new scales and scopes. We are inventing and creating digital business models for digital markets now. From my point of view, we will see an interleaved co-evolution of technology, economy, and society in the years to come. About 20 years ago, the Agile Manifesto was written, and the concept was inspired by software development and brought back to software element. Now we see more and more people being attracted by the core principles on the one hand, but trying to reinterpret and extend the approach on the other hand. Initial discussions around Agile were concerned with software and software development only. Taking Agile beyond the realms of software and broadening it towards complex software-intensive systems and product management seems to be a critical and important step in achieving business agility and allows for new and different business models. Agility improvements at the projects and products level are a good first step, but the holy grail for agility is business agility. That is to say, the ability of a whole company to rapidly respond to changes in its environment, markets, and customers. DevOps is a set of practices combining software development, the dev part, and IT operations, the ops part. It aims to shorten the systems development lifecycle and provides continuous delivery with high software quality. Culture is the most important and most difficult part of DevOps adoption. You cannot just replicate practices of other organizations as they are, only for the reason that it works in these organizations. Agile and DevOps are simply not enough if you want to reach out for cloud native. That is not to say that there is no or minor value in them. Just when it comes to cloud native, we have to find a clear way to organize co-evolution of architectural and cultural learning and implementation. On the next slide, we see an analysis on why it was and is so difficult to integrate Agile and DevOps ideas with the concept of traditional hierarchical organizations. The main goal of DevOps in an organization is to improve the value delivery rather than to reduce costs. For effective dev and ops collaboration, different organizations may need different team structures. Suitable choices may depend on the fine structure of the product set, technical leadership, transformative capabilities, and so on. For sure, there is no magical structure or team setup for every organization. However, it is useful to introduce several different team structure models, some of which are more suitable to certain organizations than others. By exploring the advantages and disadvantages of these team structures or topologies, you can determine the most suitable team structure for DevOps practice in your organization. There are effective DevOps topologies called team types on this slide, and bad practices called anti-types on this slide. We won't get deeper into this topic. The creators, Stelton and Pace, have iterated on their initial results and developed another framework called team topologies. Matthew Skelton and Manuel Pace provide in team topologies, organizing business and technology teams for fast flow, a special approach to help optimize team structure. The main idea is that a team is a living organism that must evolve and should be supported in the process of its evolution. Stelton and Pace reduce team types dramatically to just 4 main types. A large organization is likely to have at least one team that represents each type. Let's have a closer look. The stream-aligned team works on a single product or service, a single set of features, and so on. This team is a primary type in any organization. The streams can be specific customer, product, business area, geography, and so on. Some of the capabilities within a streamlined team are development and coding, testing and quality assurance, design and architecture, application security, you name it. Enabling teams consist of specialists in a given technical domain. Their purpose is to understand the problems of streamlined teams and provide assistance. Instead of dictating which choices are better to follow, enabling teams help other teams understand the constraints. Basically, they aim at growing streamlined teams' capabilities rather than providing solutions. Complicated subsystem teams reduce the cognitive load of streamlined teams that work on complicated subsystems like mathematical models, face recognition engine, transaction reporting systems, stuff like that. These teams exist because embedding a specialist into a streamlined team would not be feasible, and they are created only when a subsystem requires a very specialized knowledge. The purpose of platform teams is to make it possible for streamlined teams to deliver work autonomously. A platform is defined by them as a foundation of self-service APIs, tools, services, knowledge, and support, which are arranged as a compelling internal product. It provides internal services, which a streamlined team needs to deliver for higher level services. According to Matthew Skelton and Manuel Pei, the relationships between the teams boil down to two things. If you can achieve a goal collaborating with another team, or if it can provide you a service. This way, they identify three ways in which teams can interact. The first is collaboration. This mode is suitable when exploring new techniques and discovering new information. The second is acts as a service. It is used when a component of a system can be provided as a service by a different team. The context is clear. One team consumes, the other team provides. This mode puts a lot of responsibility on the team providing the service. It must know what exactly is needed and be responsible for what they provide, be it a testing tool or a cloud-native platform or whatsoever. Typical uses: streamlined and complicated subsystem teams consuming a platform from a platform team. And the third is facilitating. Its goal is to help other teams learn more quickly, understand technologies better, and remove problems. Team Topologies by Skelton and Pace presents a team-first approach based on 4 fundamental type and 3 interaction modes. The team type, platform team, and the interaction mode, acts as a service, are the ones that help us on our way towards cloud-native platforms. The cloud-native landscape can be complicated and confusing at first sight. Its myriad of open source projects are supported by the constant contributions of a vibrant and expansive community. Kubernetes was just the beginning. Many projects have followed Kubernetes and make up the whole ecosystem, and they are adopted by the Cloud Native Computing Foundation, CNCF. The layers on the left side of the cloud native landscape are provisioning, runtime, orchestration, and management, and application definition and development. The columns on the right side are observability and analysis, and platforms bundle different tools together to solve a large problem. There are many deep dives on the cloud native landscape in the network, and I would like to invite you to research one or some of them to get into the details. This is not our focus in this talk, and though I would like to delegate this outside our session. Platforms, different from the ones we just talked about, are categorized by CNCF in 4 groups. Kubernetes distributions take the unmodified open source code, also some modified, and add additional features their market needs around it. Hosted Kubernetes, although known as managed Kubernetes, is similar to a distribution, but it's managed by your provider on their or your own infrastructure. Kubernetes installers automate the installation and configuration process of Kubernetes. And fourth, the PaaS or container services include a broad set of application deployment tools and usually are a subset of the cloud-native landscape. The cloud-native landscape itself is not a reference architecture, but each of the blocks contains certain options and according decisions that sooner or later come into play when you design your cloud-native systems and your cloud-native platforms underlying it. The cloud-native landscape is overwhelming at first sight, and perhaps the second and the third as well. The team topologies approach might show us a way to organize learning and adoption of architectural and technological aspects and co-evolve a cloud-native platform along both dimensions. Team topologies defines a platform as a foundation of self-service APIs, tools, services, knowledge, and support, which are arranged as a compelling internal product. And we can take this more generic definition just as our starting point for a cloud-native platform. When you start with cloud-native adoption, you will do so most probably with a small group of people, perhaps organized in 1, 2, or 3 small teams. These are most probably streamlined teams collaborating and negotiating on something like a minimal viable cloud-native platform underlying their current or future work. Depending on the progress on design and agreement, there will be a point in time to carve out a dedicated platform team to follow up. So we start with a small number of streamlined teams based on a collaboration interaction mode and switch sooner or later to building a platform team in X as a service interaction mode. Each organization could and should create their own definition of a minimal viable cloud-native platform. It could be a pure Kubernetes cluster as well as a sophisticated set of services covering half of the cloud-native landscape. When you have your minimal viable cloud-native platform, you can further iterate on it, addressing further parts and choices of the cloud-native landscape, or improve usage via the API or CLI, or perhaps even build another platform team for additional purposes and services. So let's summarize. We started with the 3 eras of IT: mainframe, client-server, and cloud-native, and elaborated on the why and how of a co-evolution along the cultural organizational dimension when it comes to cloud-native. Then we identified team topologies as a key concept for the cultural organizational domain to co-evolve with an ever deeper understanding of the cloud-native landscape. In closing, I gave you a sketch of what could be described as evolutionary cloud-native platforms with team topologies.
I'm here. This is a real Lothar.
It's a real background too, I'm sure. Lovely to see you.
It's a small living room outside. My usual living room is a bit greater.
Of course. Well, we can cut to the questions quickly. Last I checked, we didn't have many, and we're at the end of the day, so I suspect lots of people are ready to head off. But no, okay, so we don't have any questions. So I think we'll just give it like half a minute more. And Lothar, you can just kind of tell us a little bit about, what inspired you to give this talk? What made you think of this as a topic to present today?
Yeah, I'm an architect by heart.
Mm-hmm.
And I like to ask questions that perhaps are a bit different to others.
Yeah.
And I hear many talks about cloud-native platforms, and many of them, as well as DevOps talks, focus on the technical side.
Yeah.
and there's only a small part of it telling, and cultural things are important as well.
Yes.
This is not satisfying for me as an architect, because I think thinking about a fully fledged architecture, having a cultural architecture and a technical architecture interleaved with one another is the only thing that can fit such a purpose.
Absolutely.
So I try to bring these things together.
Mm-hmm.
I see that many discussions about DevOps do not go in the right direction. I think it's time to think about the original Agile model, the original DevOps model. Mm-hmm. They are 15 to 20 years old now. Mm-hmm. And we have to think about why it is difficult to bring these to more modern organizations. And it's really important for me to understand that this industrialization of IT, and I'm long enough in my job, I had those periods where industrialization of IT was the optimization goal to go. Mm. But now we have to leave this. And we have to understand why we have to leave this. Mm-hmm. Because in-depth studies of what DevOps means and what Agile means, this does not fit into a hierarchical organization, and we see this all the time.
Yes.
So I like to see what are other approaches, and those two mainstream approaches, Agile and DevOps, are not enough. If I would have had a time for a longer talk, I would, for example, have talked about Lelou, reinventing organizations. Mm-hmm. So something like an evolution on the cultural side, mm-hmm. Going back to the Stone Age. But I like this approach because many people do not understand that they have 6 stages there. Mm-hmm. And you need for these modern approaches to be in the 6th state. Mm-hmm. And if an analysis where we are right now tells you, okay, you are in the 2nd or in the 3rd, then you have to make yourself clear you cannot go this long a distance in just one step. So really understanding how things imply one another was very important for me.
Yep.
And this is my thinking. And the other one was a very profane, so to speak, thing, because I had my difficulties to record the sessions. I wanted to talk a bit more on technical stuff, mm-hmm. but having these 3 streams, the video of me, the video of the talk, and perhaps dynamics of a demo, and the audio was really hard for me. And I'm just learning now how to do that.
Yes.
And on the other hand, I at another research right now, it's not really that good to have talks like that on the internet, because those identity thieves can really make use of videos of you as a real person, of you speaking as a real person.
Okay.
So I'm now studying, I have my manuscript, I have written down all the English.
Yes.
What does actual technology on text-to-speech deliver? Mm-hmm. And what do actual AI talking heads is one of the phrases they use for that. What can they deliver?
Yes.
And then I will make it perhaps a bit longer and publish it on my own Vimeo channel.
Okay, great. Well, it's good to know because that means people can look you up and also potentially see that at a later date as well. And we do have a question now. What are the main blockers to apply team topologies as defined in the book from Manuel Pice and Matthew Skelton?
They go through all those team types, but I focused on the platform team type here.
Okay.
I do not know whether I understood your question.
I think it was what are the difficulties with implementing it, right? Could you switch back to what are the main blockers to apply them? So
one of the main blockers to apply them is that you have to have people who are not really in the evolution, but have done it 1 to 3 times before. so that they are aware of the problems that you might face, and that they might be able to really coach and consult you on the way to go you are going now. As I told, for a cloud native platform, you have perhaps a small team of, let's say, 7 or 10. In most organizations, this is the number you are facing. Then you have this team. What stages do those people have to go through until they are at a point, so to speak, to split and carve out this platform team? What can you see from the outside as the experienced person? And what is perhaps the sensing of the people in the team? Really seeing themselves, okay, we are ready now. We are ready to split. And we have a clear understanding, and we have brought our own concepts, and we have brought our own ways to cope with that.
Okay.
And this brings another problem in the organization, and this is a thing you have to deliver as a coach or consultant as well. You have to make sure that this team is something like a capsule. If they have to go the same processes as teams around them who are in totally different evolutionary stages, that cannot work. For example, if you have an operations boss in the company telling, we have to do ITIL. And I'm facing a consulting situation where this is the case. Then you have to talk and you have to make clear, this cannot fit together. Yeah. And then you are in many aspects of the former slides to understand why this was the case, why ITIL might be a good approach and perhaps is, and certainly is. I've worked in these environments as well. It's a good thing to do if you are in a mainframe world and if you are in a client-server world, but it's most probably no longer if you want to go into a cloud-native world. And if you do not do this break cleanly, just trying to do as you did before in the Kubernetes world as well, then you are doing things badly wrong. Because it's very hard then to step back and really initiate learning and doing things new and the other way around.
So everyone really has to be on that same page about the new way of doing things.
Yeah, for example, what do you do if your sales managers of your consulting company, I have a leader of the data center. He wants to introduce Kubernetes. What can we give to him? What is the right answer? You should not consult him. Because if they do not come together as ops part, that's the leader of the data center, and people of the dev part, then you are on the wrong side. When will you introduce this collaborative approach? So these are hard initial discussions, most probably before you do real consulting. Mm-hmm. And you have to be courageous because this leads into conflict.
Of course, yeah. All right, well, I think we'll stop there. Thank you so much, Lothar. That was really great, and I really loved your answers to our questions as well. Thank you, everyone, for attending. I hope you had a wonderful conference.